Hello, friends. So, welcome to this all new session on number system. We are going to deal with the multiple topics of number system in a series of such sessions. In the first such session, we are going to today discuss number system review. Right. So, we are just going to recap whatever we have learned so far in the previous grades. This particular session would be useful for all those ninth grade students who have completed eighth grade mathematics. And so let's begin number system review. So, guys, you know that our entire surrounding, our ecosystem, all around us, we see a lot of utility of numbers, right? So your mobile number is a number, your roll number in the class is a number, so the number plate in your vehicle carries a number. So you can, when you go to a grocery shop or any other shop, when you exchange money, then there is a number. Your bank account number, your parents bank account numbers, so are numbers. So basically you see a lot of utility of numbers all around. So if you really have to understand the utility of the numbers, there are three primary role numbers play. One is definitely to count. So let us say when in cricket you hit a 6 or a 4, so you count number of runs you are scoring, right? Similarly, the marks achieved by you in any of the examination, you will see there is a number attached to it. So let us say there is a paper on mathematics which carries 100 full marks and you get 100 out of 100. So that's how you count how many marks you are getting. Or let us say how many pencils you have, how many days in a week, how many minutes in an hour, and things like that. So basically numbers help in counting. Second utility, if you may notice, for example, if you follow cricket, so Sachin Tendulkar, who plays for India, always used to wear a jersey numbered 10, right? So hence, if you see, there is another utility of numbers, and that is labeling, correct? So your flat number, your house number, your let's say parking slot number and things like that, or all where labeling is used, or labeling is done using numbers. Another utility you can also think of is order, right? Ranking. For example, someone comes first in the race, so there is a first rank, then there is a second rank, and so on and so forth. In exams like, let's say, IIT JEE, there is all India rank. So there also there is an order. You must be, given some merit rank in your class, so that's an order. So all these are utility of numbers. Now, we have also learned different types of numbers so far. So if you see, the basic counting numbers are natural numbers. Natural numbers, so natural numbers is nothing but all those numbers which are used for counting. Example, 1, 2, 3, and so on and so forth. These are the first things you learn when you take up arithmetic in your childhood, natural numbers. But then we sooner graduated into another set of numbers, which is called whole numbers. And whole numbers are nothing but numbers starting from 0, all counting numbers plus 0, 3, 4, 5, and so on and so forth are all whole numbers. Now, the set of natural numbers, please notice I am saying set of natural numbers, right? Natural numbers is denoted by a letter n. Okay, so n for natural, so n. Similarly, set of whole numbers is nothing but is denoted by a letter w. So you can clearly see w, the set of w has one extra member, that is this 0, than the natural numbers, isn't it? So hence, if I have to pictorially represent the two sets, I can say if this is my natural number set, then if I the whole number set will constitute all the natural numbers plus 0, and hence this will be called a whole number set. Now natural number set have numbers like 1, 2, 3, so on and so forth, right? Now, why did we require whole numbers in the first place? Why was 0 needed? So if you know, natural numbers, if you add 2 apples with 3 apples, you'll get 5 apples, right? So 2 plus 3 was 5, right? This was very much easy. and if you let's say do 5 plus 5 plus another number 7, so you get 12. So if you see, if you add two natural numbers, if you add two natural numbers, we get another natural number, isn't it? Another natural number. This particular property is not that simple. What I mean is, if you add two natural numbers, you always get another natural number. This particular property is called closure property, right? So we say closure property. Why closure property? Because to find the solution of a sum like 3 plus 7, you will get the solution in the set of natural numbers only. That means if you add a natural number to another natural number, you will get another natural number, right? So hence we don't require any other new number outside the set of natural numbers to find the solution of any addition operation, right? You cannot you take any number of examples. Let us say 7 plus 21 is 28. Again, if you see, this is one natural number added to another natural number, you get another natural number, right? This particular thing is called closure property, and we say that set of natural numbers is closed. What am I saying? Closed for addition. This is how we describe it. Closed for addition means you don't require any intervention, external intervention, to find the solution of sum of two natural numbers. But my friends, let us do another operation. You have studied subtraction, multiplication, division, etc. So let us now say, if I find out, let us say 5 minus 3, you know the answer is 2, right? So if you see, one natural number subtracted to another natural number, subtracted from another natural number gives you another natural number. But there is a problem. What is the problem? If I subtract 5 from 5, you now know that the answer is 0. But if someone who has studied only natural numbers, or whose knowledge comprises of, let's say, the set of natural numbers, then he will be confused. What is the solution? So hence, if you know the history, Indians Indian was the first people who came out with the concept of 0, right? So 5 minus 5 was now expressed as 0. But then this 0 doesn't belong to counting numbers or natural numbers. Belong to natural numbers, because you don't really count nothing, right? Natural numbers. So hence when 0 was added to the set of natural numbers, we got a new set of numbers, majority of which was already known, which was called natural numbers. Now we are getting another set, and now that set is called whole numbers, right? So now I assume that you have understood the concept of natural numbers and whole numbers. Now does this mean that the set of whole numbers set of whole numbers is closed for subtraction? Is this statement true? What does it mean? It means that if you choose a whole number a and another whole number b and you subtract them, will you get c, which is always a whole number? Always a whole number? Really not, right? Because you can take an example. For example, it was very comfortable if you subtract a smaller number from a greater number, like 5 minus 3, and you know the answer very easily, it's 2. But what happens if I reverse these two numbers, right? That means if I want to find out 3 minus 5, does this answer belong to the set of whole numbers? That means, will you get a solution in whole number set, in the set of whole numbers? Will you get whole number set? but a set is nothing but the collection of all whole numbers, right? So will you get a solution in the set of whole numbers? That means will you find a whole number which will fetch you 3 minus 5? Actually, no, no. So hence another set of numbers now were required, and hence now that you know that answer is minus 2, but this is minus 2 doesn't belong to what? Set of whole numbers. So hence this number is an outsider, isn't it? Outsider to the set of whole numbers, right? And hence we say, friends, that set of whole numbers is not closed for subtraction. It is definitely closed for addition, but it is not closed for subtraction. Meaning what? You will never, you will it's not necessary that you will get a whole number when you take the difference of two whole numbers, correct? Hence, to remove this problem, or let's say to remove this incapability of finding the difference of a higher number from a smaller number, we coined another set of numbers, and now those are called integers, right? So what are integers? Now integers are nothing but a set of whole numbers, set of whole numbers, that is 0, 1, 2 and all that, plus set of negative counting numbers, and those are -1, 2, -3, -4 and so on and so forth, guys, right? So this is nothing but we have now found out a new set of numbers, and those are called integers. Now the set of integers is denoted by z, and z is for Zahlen. This word Zahlen, right? It's a German word, Zahlen, that means numbers. Okay, so hence integers are a new set of numbers which comprise of not only the whole numbers but negative counting numbers. So pictorially you can represent integers, and the entire set of numbers that you know now is like this. How do I represent pictorially? So hence, if this is my set of natural numbers, then you add 0, you will get the whole number set. Then you add negative numbers to it, you will get integers, isn't it? So hence natural number belongs to the set of whole numbers, and the whole numbers now belong to the set of integers, right? Another way of pictorially representing it is called the concept of number line. So if you draw a line, infinitely long line, let us say this is my line and it is going in both the directions, and let us take any other point as, let's say, 0, right? Starting point as 0. Now divide the line into equal intervals, let's say 1, 2, 3, so that the difference between the two units or 2 points is always same, correct? So I'm doing it with rough hand. What you can do is you can take a ruler and draw neatly. So this point is represented as 1. So this is exactly, what is this distance? This distance is 1 unit, isn't it? And this is 2, this is 3, likewise 4, 5, 6, and this goes on. Similarly, on this side you'll see -1, -2, -3, -4, -5 and all that. Okay, so if you see, all the integers can be represented on a number line which is extending infinitely in both the direction. You have to just put one starting point, that is 0. We have put it here, and on both the sides, on the right hand side and the left hand side, you will see infinitely many numbers which can be represented on the number line. It's just the constraint on the space, hence we are not able to draw longer number lines. But philosophically speaking, there extends an infinitely long number line where all the integers could be accommodated and represented such that the difference between consecutive integer is always the same. Correct? This is a very important concept. Now, what is the learning so far? So we learned these points. First, natural numbers are closed for what? For addition. We know that two natural numbers added will fetch you another natural number. We also learned that natural numbers are not closed for subtraction. Not closed for subtraction. Third, we also learned that whole numbers is nothing but w, which is equal to n plus element 0, right? So natural number added to an element, or 0 added to the set of natural numbers, you'll get whole numbers. And we also learned, same as natural number, whole numbers are closed for addition, but again whole numbers are not closed for subtraction, and hence we needed some external intervention, and we formulated new set of numbers which are called integers. Now, which are nothing but, what are integers? Denoted by letter Z for Zalin, and it is nothing but an element comprising of infinitely many numbers: -3, -2, -1, 0, 1, 2, 3, and so on and so forth, right? And then we learned integers are closed both for addition as well as subtraction, isn't it? So if you take any two integers and you try to find out either sum or the difference, you will always get a integer. So very important property of integers. And then one more thing is number line. We understood that all the integers, whole numbers, and negative accounting numbers can be represented on a number line, isn't it? This is what we learned so far. So in the next few sessions, we'll understand why did we require any other set of numbers, or what happens if we try to divide and multiply two integers. What should be the result? So let's meet in the next session. Thank you.